Hey guys, welcome to Outcome School. I'm Amit and today I'm going to teach you what are embeddings in machine learning. So let's begin with the learning as usual. Okay, so first let's try to understand with the definition of the embeddings. So embeddings are the representations of objects like text, images and audio into a vector according to their properties and the relationships between them. So we will try to understand this with the examples and the use cases so that you understand it in a better way. So for that, if you see on the screen right now, we have the text embedding model and the audio embedding model. So this is the model, and what we will do, we will pass the text, the document data, the text data in this model, and it will give you a vector representation for that. Similarly, if we have some audio, we can pass through the embedding model, and again we will get some audio embedding vector like this. So ultimately what we are doing, we are converting a format into the vector format so that machines can actually learn about the similarities. So it enables the machine learning model to find the similar object, and that is going to help us in many use cases. And for that we also need to learn about the vectors. So let's try to learn few things about the vectors as well. A vector is an array of numbers that define a point in a multi-dimensional space. So here we have the 2D space and here we have the 3D space. As you can see, a point here 4, 5. So 4, 5 is a vector here and that is present in a 2-dimensional space. Similarly, here we have the 4, 5, 3. So this is a point. A vector is an array of numbers that defines a point in a multi-dimensional space. So this is the point. So this is the array, this is a vector, and this is present in a 3-dimensional space. So these were the examples of vectors in 2D and the 3D space. And what we will do now, we will again look into the definition of embeddings with what we have learned so far. So here is the definition once again. Embeddings are the representations of objects like text, images and the audio into the vectors. So this is what we have learned so far according to their properties and the relationships between them. So we learn about this and this now. So for that we will take the example of the dog and the goldfish. So here we have properties. So we are going to learn about the properties and the relationships. So first let's try to understand the properties. So for example, for the dog we have the properties like these: high friendliness, medium large size, high energy. So here we have the low, small and the less, like this for the goldfish. So these are the properties that we have defined for the dog and the goldfish. As we have learned that vectors can be defined in 1D, 2D, 3D, and it could be anything like n is equal to 1000, 2000, it could be anything as such based on the requirements. So here if you see, if we are saying that we will take only one property like friendliness, so because of that we will have only one D space here, and because the dog has more friendliness than the cat than the goldfish, so we are keeping the dog here and we are keeping the cat in the middle of the goldfish and the dog. So here these numbers are defining who is more friendly than the others. So that is what we have done here in 1D space. Similarly, if we have to define something in 2D space, because we have the two properties like friendliness and we have the size, because of that we will have the 2D space, and as you can see, again with the help of the numbers we are representing the dog, cat and the goldfish in this 2D space. Similarly, if we have three properties like size, friendliness and the energy, so because of that again we have the 3D space here because of three properties. So here we have defined the dog, cat and the goldfish. So this is how the vectors are helping us in organizing the properties in the n-dimensional space based on the requirements. As earlier I mentioned, it enables machine learning models to find the similar object. Now it will make more sense when we see this. Okay, so we will wait for that. And before moving forward, I want to highlight that actual embeddings will have hundreds and thousands of dimensions for the embeddings, not just 1D, 2D and 3D, because of the nature of the data that we are going to play with. And now let's get back to the point, which is it enables the machine learning models to find the similar objects. So embeddings are going to help us in finding the similar objects. So when we feed the input features in the embedding models, that model is going to provide us the vector representations, and that is going to look like this: 9, 4, 8, 8, 6, 7. Like this, we will have the vector embeddings. So let's say we have the data set that we are going to feed into the embedding models, and that is going to generate something like this. So after the generation, when you observe this, because dog and puppy are related to each other, so that is why they are close to each other. Similarly, cat and kitten are similar, right? Because of that, they are again close to each other. And as we know, the goldfish and the dog are quite different from each other, so that is why they are placed far from each other. And if you see this thing, this embedding is going to help us in finding the similar object, because we can easily calculate the distance between two objects at any point in time. So this is how the embedding helps us in finding the similar objects. And now we are going to discuss the examples and the use cases of the embeddings. So embeddings are created by training models on the large corpus of data. So we have some already created models. So one example is word to vec, and that is for the text. So if we have some text data that we can feed into this model, and that will give us the embeddings, which is what? The vector representation of the data. And similarly for the images, we have the ResNet. So there are many models available in the market for the different use cases that we can use as the embedding models to create the vector representation of the data that we have. And now it's time to learn about the use cases of the embeddings in the machine learning, how finding the similarities between the object is going to help us in solving many use cases because of that vector representations. So now let's begin with the use cases. So the first is document similarity. So we can feed the text into the embedding models to find the vector representation of those data, and that will finally help us in measuring how conceptually similar texts are to each other because of the vector representations, right? Similarly, content based recommendations. So here again we can feed the items. So for example, we want to create a movie recommendation system. So our data will be video, title, descriptions. So those things we will pass into the embedding model, and again it will generate the vector representation for those data, and that will help us in suggesting similar items based on the feature embeddings. Features are video, title, descriptions. And the next example is collaborative filtering. So here what we are going to do, we are going to push user as well with the items. So with the video, so for example, video recommendation system. So items are video, title, text. But in addition to those features, we are going to push the users as well. So here same thing, but we will have extra users on the top of that. And how this is going to help us, let's try to understand. So suppose for example, I watch videos related to football, and you do watch the videos related to football, but in addition to football, I like cricket as well, so I do watch the videos related to cricket. So what this collaborative filtering will do, because it has the videos plus the users as well, and it knows that we both are similar users, right? So because I watch football plus cricket and you only watch football, so it can recommend you cricket as well, and that was not possible in the content based recommendation. So this is how adding this user in that embedding thing is going to help us in serving the new videos related to cricket to those users as well. So this is how collaborative filtering is helpful, and this also uses the embeddings as well. And the next example is image retrieval, finding visually similar images. So again, what we can do, we can feed all the images into the embedding models, and that will create the vector representations in n-dimensional array, and that is going to help us in finding similar images. So we can simply find the visually similar images by using the embeddings. And the next is face recognition, creating face embeddings for the comparison and the identification. Again, we are going to feed all the images of the faces into the model to generate the vector representation, and that embedding is going to help us again. Next example is vector database. Now we have seen there are many vector databases. There they are using the embeddings to store and query the data based on the semantic similarity. And finally, we have the large language model, which is something everybody is talking about. That also uses the embeddings to convert the tokens into the vectors. And I think I might plan a video on how embeddings are internally used in the large language models. And I hope this video has helped you in understanding what are embeddings in machine learning. So that's it for now. I will see you in the next video.